Hey there, this is day 2 on confidence intervals for means. We're going to call this section 10.1 part B. Still with the same goal to be able to construct a confidence interval for a mean. So let's see what we remember from last time. Let's try this example. It says a 2023 Pew Research Center study interviewed a random sample of 1,410 American adults. The average number of books read in the last 12 months by members of the sample, including those who reported reading 0 books, was 11. So that's our mean. We're given that mean there. With a standard deviation of 17.5 books. So there is a clear variety in the spread here. Constructed and interpret a 95% confidence interval for the mean number of books read by all Americans in the previous 12 months. Okay, that was our sample. We want to now get an interval of plausible of numbers of books for all Americans. Okay? I want to see if we can generalize. So let's walk through this procedure once again. So let's start with step 1. State your parameter. Now this is mean, so we're going to say mu is the true mean number of books. Read by American adults in the last 12 years, so in past year. All right, we've got our parameter. Now, what is the test that we're going to be doing? That is a 1 sample t-test for a mean. All right? Sorry, my t got a little funky there. Whoops. All right, we are doing a 1 sample t-test for a mean. So, before we want to get into all that work of doing it, let's check the conditions. All right, condition 1, do we have a random sample of American adults? Excuse me. Let's just go back up there. It does say we have a random sample of 1,410 American adults. Perfect. All right, number 2, do we have approximately normal distribution of number of books read? Well, it doesn't state that. So, but it does have more than 30. So 1,410, that's way more than 30. So we can say yes by the central limit theorem. Okay. Remember, our options is the population proportion normal? If not, then go on to the central limit theorem. And if we don't have that, then we can try to plot it and see if it at least has no skews or outliers. And we didn't have to get to that point now, and we wouldn't have the information to do that anyway. Last one, since it's a random sample, do we think that 1,410 is less than or equal to 10% of all U.S. adults? Well, we have over 300 million people in our country. I think there's more than 14,000 adults. So that's a definite yes. So our conditions then are met. Okay? I'm going to put this in a box and show that we're good to go there. So we can move on to our actual formula. Now, in order to do the formula, we need some statistics here. And normally we either are given them or we have to find them using one variable stats. Well, we happen to be given them. Our x bar was 11. Our s sub x is 17.5. Our t-value. Now, remember for our t-value, our t-star, you can go and look at your table B, or you can use inverse T in your calculator. But what we're going to use here, if we use table B, we're going to have to use the degrees of freedom of 1,000. So I'm going to make note of that. So T star, if you use the table B, degrees of freedom would be 1,000, because that's the highest, the next one that below what we have, because it's such a range there. I would get the T star value of 1.962. Now, if I went to inverse T, I can actually use the degrees of freedom of n minus 1, so it would be 1409, and I can use 0.025 as my, I think to the left, that's 2.5% on the tails, and I'd get something very similar. So I wanted to show you that. If you go down to second vars, hit number 4. Our area, this is going to be in the tails. You got to make sure you know that. It's 0.025. Our degrees of freedom was 1409, so n minus 1. And if I go and get that, it gives me negative 1.962-ish, or positive. It would be the right side. So the T star would be the positive version of 1.96-ish, and that's super similar to what I got from the table either way. So that's what I'm going to use. In my formula is x bar plus or minus T star times the standard error, which is S over the square root of n, as we're doing a sampling distribution. If I plug in, I've got 11 plus or minus 1.962 times 17.5 over the square root of n, which was 1410. And when I do that, I get a margin of error of about 0.914. Not a huge margin of error. So, my interval for mu ends up being between 11.914 and 10.086. There is my confidence interval. And I can interpret that by saying, you know, with 95% confidence, or with a 95% confidence level, something along those lines, I believe the true mean number of books read by U.S. adults last year is between 10.086 and 11.914 books. And there is my interpretation. So that's the steps we talked about last time for a confidence interval with the means. Again, the big things that are different there is you need the X bar, the standard deviation. You also need your T star, which is a T distribution, similar to a Z distribution, but slightly different. Now, today I want to talk about some follow-ups. So, first question. Now, our last one was based on 2023. It says in 2020, Pew reported that the American adults read an average of 13 books in the previous 12 months. Does your interval from Part A provide convincing evidence that 2023 is different than 2020? Well, if we look at our interval does not include 13. So yeah, it seems different. This is a pretty confident, we're pretty confident in this mean based off of this number of people who did it. So yeah, we could say something along the lines of yes. 13 books is not included in our 95% confidence interval. So I believe it isn't 13 is not plausible for this year, and therefore is different. All right? So we're looking at our confidence interval to see what it means. Now, we also did talk briefly about interpreting these confidence intervals in context. So it's very similar to that of proportions. Just a review, might be worth checking your notes or your sheet, but if we were to select many random samples of 1,410 U.S. adults, we'd say about 95% of the confidence intervals created would capture the true mean. Last year. All right, so just some follow-up questions with an example like this. So I'm going to give you a second example to try. I have a situation. I also have some summary statistics there for you. It says, in an effort to determine the average number of calories that HHS males consume in a day, Mr. Neary randomly selected 20 food logs the male students kept in his fitness education classes. Using the summary statistics provided, construct a 95% confidence interval. We probably should use a different value, but we'll keep with the 95% confidence interval for the mean number of calories consumed by HHS males in a day. So I'm going to have you pause and try this. Make sure you're able to do this on your own, and then you can unpause it and see. All right, so our parameter mu is the true mean number of calories consumed in a day by an HHS male student. We're going to be doing a one-sample t-test for means. If you look over to the left, our conditions are all met. Now, I want to make one note here. We aren't stating that the population is not approximately normal. That's not stated. We don't have more than 30 in our sample, so we can't use the central limit theorem. So we'd have to take our information here and essentially put it on a number line and look at the minimum, the quartile, the medium, the quartile, and the max of a box plot. So if you looked at a box plot, it's a very symmetric looking. There's no clear skews or outliers, so it looks good enough to proceed. So we're going to say that. We're going to say there's no clear skew or outliers and it's okay to proceed. Everything else fits. Now, this information was given. This information you have to use your table or your inverse t to find. Degrees of freedom would be 19. So when plugging into our formula, we get all of this. And you get an interval that goes between 2256.42 and 2760.28, which means if we wanted to interpret that, we have a 95% confidence level saying we believe the true mean number of calories consumed by an HHS student is between those two values. Okay? Now, that's the confidence interval. What if we were asked a follow-up question like this? It says the American Academy of Pediatrics recommends around 2,500 to 3,100 calories a day for teenage boys. Using the interval created in Part A, do you believe HHS males are eating within the recommended guidelines? So 2,500 to 3,100. We had 2225 to 2760, so there's some overlap. It's not all within the same interval, but because there's overlap, we don't have enough evidence to say that we're not. It does seem a little bit lower than what's recommended, but there's overlap in there. So every part of that confidence interval is equally likely, which means we have plenty of that, which fits into the 2,500 to 3,100 calories So there is overlap. So we're going to say no evidence against. Okay, if you want to test it more, you could get into a hypothesis test, but we're not going to do that today. So that is section 10.1b, day 2 on confidence intervals for means, and just some follow-up questions with these confidence intervals. All right, that is our lesson. We'll see you next time.